Today's lesson is on multiplying and dividing with significant digits. Yesterday we covered the 5 rules pertaining to significant digits and how to determine if something is or is not a significant digit. When multiplying and dividing with significant digits, the answer will have the same number of significant digits as the number with the least number of significant digits. So, the key concept example that they give you, this does pertain to physical measurement. Notice here that both of the units there are feet, so it's a physical measurement. Basically what they did is they multiplied 43.2 times 21 feet here, giving us 907.2 feet squared. Okay, when we multiply feet by feet, that would be an area, and we get the feet squared. Now, the next best thing after you do your computation, your calculation of 907.2, is to go ahead and determine how many each of the measures had, how many significant digits each of them had. So 43.2, these are all non-zeros, so they had 3 significant digits. 21, 2 non-zero numbers there, so it had 2 significant digits. Now, remember, the directions said it is the least number, so the least number would be 2. So we would have to round to 2 significant digits. Looking at our answer here, 907.2 would have 4 significant digits. We need to round to 2. So the easiest way to go ahead and do that is take your 907.2. Well, we look at the 9 and the 0, there would be 2. You look at the number behind it, that's 7. The 7 would round up. So when it rounds up, you would get 910, which would have 2 significant digits, the 9 and the 1, and we know that 0 would not be a significant digit. So down in example 1 here, notice we do have physical measurements with meters again. Maybe go ahead and put your significant digits above each of the given numbers. 810 would have 2 significant digits, and 3.9 would have 2 significant digits. So the least amount obviously would be 2 here. They both actually have 2 significant digits. So we would need to round to 2. So do your computation of 810 divided by 3.9. We'd come up with 207.6923. We need 2 significant digits there. So on this problem right now we have 7. So I'm going to look at my 2 and 0. Look at the 7. That 7 would round up. I would get 210 meters here. Now notice it is not meters squared. I'm not multiplying meters times meters to get meters squared. So it's 210 meters. Same scenario in 2. Determine how many significant digits here. Both non-zeros. These zeros are to the left of the decimal point, so these would not be significant. This would have 2 significant digits. 53.7 actually has 3 significant digits. So we would need to round to 2 significant digits. So go ahead again, do your computation. After that, we divide those numbers, we get 102.42085. We need to round to 2 significant digits here. So we look at that 1 and 0. That 2 would actually round down. So we would come up with 100 centimeters. Now, looking at your answer here, really it only has 1 significant digit. These zeros would not be significant. That's just the way it worked out with the rounding. So our answer would be 100 centimeters. Example 3, significant digits here. Zeros are not. 9, 2, so we have 2. Also, we have 2. We are multiplying there, so go ahead and do our computation there. Once we multiply those 2 numbers together, we need to round to 2 significant digits here. Remember, these zeros would not be significant. Here's actually our first significant digit, and then here would be that second significant digit. We look at the number behind it. There's 6. 6 would round up, so we would get an answer of 0.085, and this would be feet squared because we multiplied feet times feet. Our answer 0.085 has 2 significant digits. Example 4, we're dividing here again. 360 would have 2 significant digits. 13.715 would have 5 significant digits, so we would need to round to 2. So we'll go ahead and do our computation. After we get our computation, we'll go ahead and do our significant digits, and we need 2 of them. Well, the 2 and the 6 would be significant. Look at the number behind. The 2 would round down, so we would have 26 miles here for 2 significant digits. The final 2, evaluate using correct significant digits, and we need to write this in scientific notation. So you go ahead and look up here. We have miles here, so it is a physical measurement. We are multiplying, so I'm going to go ahead and multiply, steal my 2 numbers. We have 3.6 times 13.715, group that together. 3.6 has 2 significant digits. This would have 5, so we would need to round our answer to 2 significant digits. Multiply those together. The next thing we would take and group our exponents together. And remember, when you multiply, you add your exponents. Same base number 10. We would have 3 plus 3. After our computation here, we would get 49.374 times 10 to the 6th power. Now, we wouldn't be finished here for a couple reasons. Reason number 1, this is not in scientific notation. So I'm going to go ahead and convert to scientific notation first. Put that number in scientific notation would be 4.1 or 4.9374. I need to get back to that number, so I would multiply by 10 to the first because it would move back 1 space. Now, reminder that 10 to the 6th does not just magically disappear. We'd go ahead and drop that down, saying that that is 10 to the 6th power. We would come up with 4.9374 times 10. Well, same base, multiplying, add those exponents 1 and 6. We would come up with 4.9374 times 10 to the 7th power. Still not finished here. Reason why is we're using those significant digits again. Remember, we need 2 significant digits for this answer here. So I would look at, well, here's my first significant digit, 4. Here's my second. Those are my 2 significant digits. Look at the number behind. The 3 would round down. So our answer here would be 4.9 times 10 to the 7th. We multiplied here. This would be miles squared. Last example, 6.0, 2 significant digits, 1.715, 4 significant digits. So we would round to 2 significant digits here. This operation here is division. Steal those whole numbers here, or those numbers I should say. Group them. 6.0 divided by 1.715 in a set of parentheses. Second set of parentheses, go ahead and take off your base and exponents here. So we have a base of 10. It has an exponent of -2 and -2. Remember, we are dividing. When you divide, you subtract your exponents. So we'd have -2 subtract -2. Work down our paper. There's my computation when I divide those numbers. Times 10, well, -2 minus minus would be a plus, so -2 plus 2 is going to give you the power of 0. Now, this is in scientific notation. That first number here, it is at least 1, but less than 10. Only problem is we have to go down to 2 significant digits. So that was that least value, 2 significant digits. So 3 and 4 are significant. Look at the 9. 9 rounds up. So we would come up with 3.5 times 10 to the power of 0, and this would be miles. This will conclude calculating significant digits.